Hello everybody, EY here. So you may have heard about the video where I forced EW to speedrun Floodfield in under 6 minutes. And today, unfortunately, he is getting his revenge because I have to speedrun Maze in 6 minutes. And so if you don't know what Maze is, it's pretty simple. You input the amount of rows and amount of columns. So here there's 5 rows and 7 columns. And then you input the maze. And then you input the starting and ending points. So here we'll be starting in this cell because it's 0, 2, and this is 0 indexed. And they'll be ending on the top right corner. So this should be 11 cells because we're including the starting point. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our program should output 11, and this is the test case we'll be using after finishing our program. So let's get started, and you can see the timer in the top right corner here. So let's start it in 3, 2, 1. Let's just include our normal header files, and we'll be using BFS. So let's include our queue and using namespace std just for the sake of time. And this will be an n by n maze, so the rows and columns can be different. We'll just create a regular array just for simplicity. And distance array for our distances. Let's write the input for the maze. And then let's also use this nested loop to initialize everything in our distance array to 0 because that means we'll use that to mark unvisited. Then let's create a queue using pair int int because we're storing x and y. Let's push and let's create starting points 2. It's coming up on 1 minute and 32 seconds. Alright. Then we will initialize our start x, start y to 1. And let's push our points for the start to the queue. Alright, and then we'll check to make sure the queue is not empty in this while loop so we can rerun until the whole matrix is filled, distance matrix. And grab the front of the queue. And then make sure we pop the first element so you don't get an infinite loop. And then we'll have our current x is equal to queue front dot first. Then our current y is equal to queue front dot second. And then we should also create some distances. The directions. So let's create our directions array. Well, 4 directions today, and they'll be up, down, left, and right. Let's make sure we got our distances correct, which I believe they are, so let's continue. Then we'll loop through the distances. There are 4. Let's have a new x, which is the current x, plus the distance. Sorry, I keep saying distance. I mean direction. And then, there's an error here. Yes, I put in the wrong index. We'll check to make sure nothing is out of bounds. And then at ones will equal barriers, so we don't want to go into a barrier. Let's extend our window here. And then this is the cases we don't want, so we'll continue in this case. And then we'll check to see if it's unvisited, and if it is, we'll push it into the queue and set that distance to +1. Here, if it's valid, just equal the current one +1. So we're just going one step to the next cell. And then we'll push the next point to the queue. And I believe that is all for the BFS. So then we'll just see out the distance for the end points. Alright, stop there. Alright, so that took 5 minutes and 14 seconds. Now we will run the test case, and if the test case fails, we'll have to debug the code in the 45 seconds we have remaining. So let's run the code. Input our maze. And the moment of truth. And this is correct. So we have successfully solved the maze problem under 6 minutes. Take that, EW. Anyways, see you in the next video. Bye.